Well, lesson 7.2 is going to show us a good application of ratios, which is the previous lesson that we just talked about. So what a unit rate, a rate is just comparison of two quantities that have different units of measure. That's the key part. If I'm comparing how many laps I ran per minute, or how many dollars something cost per ounce, that's a rate, a comparison. So I listed several examples here and what you're comparing. But when you talk about a unit rate, that is when you're comparing one unit, a rate for which the comparison is to one unit. And I put a note there that a unit rate almost always uses the word per. So, for example, 14 miles per hour is comparing 14 miles to just 1 hour. When we say per pound, we're talking about per 1 pound, per box, per 1 box. So if you wanted to kind of comparison shop and find out what would be the best deal, unit rates are used all the time. In fact, at Kroger, there's a little yellow tag on every shelf under each item, and it actually tells you the unit rate. So it's very easy to compare there and find out which one is the best deal. So I gave an example, 2 different brands of a can of corn. They're different size cans, so they cost different amounts. So I know what 15 ounces cost here, and I know what 20 ounces of the Great Value brand cost, but I need to figure out how much 1 ounce costs for each one. And that would be finding a unit rate, and that would help us compare. So we find the unit rate for each one, and it helps to write out what I wrote right here. When you're finding your unit rate, sometimes you have to figure out, well, which way does it go? Do I do ounces divided by dollars? So you ask yourself, do I want to know ounces per dollar, which you could technically do, or does it make more sense to say dollars per ounce? If you're trying to determine an amount of money to spend, of course you want dollars per ounce. So per indicates divide. So you take your dollars, if you want dollars per ounces, and you divide by your number of ounces. And then you would show the support for the long division, but when I did it, I wrote what I got right here, this 0.059333333, and so on. Well, this is money, so money, you want to always, let's make a note here, money, unless told otherwise, you're going to round to the nearest, apologize for the cough, nearest cent, which is the nearest hundredth place. So if I round that one, I think I put it on the next page there. Well, maybe not. Bear with me here. Well, I wrote it right here, and I didn't actually round it. When you're comparing, and the reason I didn't, I know now, the reason I didn't round it yet is because I'm comparing it to the other one, and I might need to go more than 2 places. Say the other one might be 0.05 also, so I need to see the number after it. So I'm just going to leave 3 or 4 places so that I have enough to be sure I can compare. So on the next one, I'm going to have you go ahead, and you might take a minute and see if you can remember how to find the unit rate. Number 1, we did it for Del Monte. Now you're going to do it for Great Value. So just think about it for a minute. And I'll give you a hint. You want dollars per ounce. And per is divide. So look back on the previous page, look at your dollars. It was $1.20, so I can just write 1.2, and it was for 20-ounce can. So again, go over to the side, do a little long division. over here. So 1.2 divided by 20. 20 doesn't go into 12. Oh, got a couple of zeros over there. 20 into 120 would be 6, and that's 120 evenly. So I don't need to go any further. So this is, that's how we would write it with a dollar sign, 0.06. So that's 6 cents per ounce. So per ounce. The labeling is really important on the units. And the other one was 0.059. So the best value, the conclusion here would be that Del Monte is the better value. So Del Monte is the better value. Because it was approximately 0.059 per ounce. So got another example here. Actually got 2 more examples. So if you want to just go ahead and stop the video, I would try them and then come back, unless if you're totally confused right now, you might stick with us. Let's do another one together before you try one on your own. So you got a 3-pack of paper towels for $2.79 and a 6-pack for $5.46. Which is the better deal? The key to working both of these is to think about what am I looking for? What per what? So in this particular problem, let's separate it. I like to kind of make a little column for the 2 things. You've got a 3-pack and you've got a 6-pack. So it looks like we want to find we want the cost per roll. Because when it says 3-pack, it means there's 3 rolls of paper towels in there. So we want the dollars per roll. Over here, we want the same thing, dollars per roll. Well, let's just fill in what we have. We have $2.79 divided by the number of rolls in the 3-pack is 3. Whereas over here we have $5.46. That's for 6 rolls. So that's divided by 6. It makes sense that when we divide here, we're going to get the cost in each situation for 1 roll. So we've got to do some long division. I'm not going to do that for the sake of the video, but you know how to do long division. On this one, you would show it kind of out to the side, so don't treat that like scratch. You need to show it. That would be, this one comes out to be exactly 0.93. And over here, this one comes out to be 0.91. So this is 93 cents per roll, which you should write. When you're asked to find unit rates, you need to put the full label, and that's per roll. So, which is the better deal? Well, the 6-pack. The bigger package of things is not always the better deal. It is often, but not always. Just circle this one. Best deal. So after doing 2 examples there, you should feel pretty confident maybe in trying example 3. So this is a good one. It's our last one. So think about it. Just separate your problem into Jim and John and work on those and then come back. All right. So John worked so many problems in 2.3 hours. Jim worked 15 in 0.75 hours. Who had the fastest work rate? Well, so for the rate, we want how many problems per hour. So we'll just separate it. John, if we want problems per hour, his problems is 40. His hours is 2.3. I'm going to go through this division with you because we need to remember how to do this type. And Jim, we still want problems per hour, and he's 15 problems per 0.75 hours. So remember, when we discussed how to work with decimals, we talked about how when the divisor has to be a whole number. So the divisor, 2.3, you're going to have to make it 23. That's moving the decimal one place to the right. So if you do it for the divisor, you have to do it for the dividend. So that would become 400. Now you can just divide 400 by 23. So over here on this one, if you move that over twice, which you need to do, and then you get your, oops, sorry, it's not 15 divided by that. We moved it two places, so it's 1500. Then you can divide. So come over here, I'll do one of, well, you just do that on scratch paper, but I'm going to, the first time you divide, you might not know exactly how many places to go, but on this one, I got 17.39, and that wasn't exact. I just kind of stopped, then I jumped over here, because remember, you're just trying to compare right here, and I've got enough to kind of, to be able to compare these. When you divide the other one, it goes evenly. This one comes out to be 20. So remember, this is, both of them are problems per hour. So John is working about 17, so I'll just put approximately here. And Jim is working 20 problems per hour. You know, and think about it, he did 15 problems in 3/4 of an hour. So every 15 minutes he was doing 5 problems, so it makes sense that in an hour he could do 5 more, so it'd be 20. So who has the fastest work rate? Well, Jim does. Jim is the answer, and then 20 problems per hour and 17.3 blah 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 problems per hour. This is support. And again, you would show your long division. Okay, you might make a note of that here. Show long division. It's not on scratch paper, but show it out, you know, to the side. And that is a lesson on unit rates. It's very applicable. There's lots of things where it makes sense to find a unit rate to be able to compare and make decisions about which way to go. So I know you'll love the homework for this, and when we come back next time, we'll be talking about something even more fascinating than unit rates.